Forgot to record that. That's all right. They can see the answers now. The answer is anywhere from, what did I choose the answers to be for this? Anywhere between 700 and 900. Okay. And then this one was anywhere between 8 and 12. Okay. All right, we're on lesson 1.3, properties of numbers. Let me explain to you another. I just went over this in pre-algebra today with my pre-algebra students. So I need your attention. I really want you to get settled, and then I want your attention. I don't want you looking at, just I give you 10 seconds to be completely settled, so that you are paying attention to me. You have 5 seconds. All right. So I expect your attention on me now. For real. Properties of numbers. These are rules. Rules to follow. Most of these rules you already know. You just didn't know what they were called. Okay? Most of the rules that I'm going to go over with you right now, you already know. You just didn't know they had a name. One of the rules that I'm going to talk to you about is the identity property of addition. The identity property is this. Whenever you take any number and you add 0 to it, what happens to the number? Stays the same. That's called the zero property of addition, or the identity property of addition. You all know that. If I take any number, I don't care what it is, and I add 0 to it, the number keeps its identity. That's why it's called the identity property of addition. Because when you add 0, the number still keeps its identity. Does that make sense? What if I had something like this? What if I had an x and I add 0 to it? What's the answer? X. It doesn't matter, right? You add 0 to anything, it's still that number. It keeps its identity. Okay. Another one. You have, do they do multiplication? Yeah. The identity property of multiplication. What do you think the identity property of multiplication is? You take any number and you multiply it by 1, it still retains its identity, right? It's called the identity property of multiplication. No matter what I do, if I multiply it by 1, the number still stays the same. It keeps its identity, right? You've known that forever. Did you know it was called the identity property of multiplication? No. That's what it's called. That's one of the rules. Make sense? These are just rules that you're going to follow. And you have been following. You know this. What if I had an ugly one like this and I have y times 1? What's the answer to y times 1? Y. It doesn't matter what it is. If you multiply it by 1, it keeps its identity. Make sense? Excellent. There's a couple of other properties that you need to know, okay? They write them out differently. They write them like this. Let's just say this. What if I have 5 plus 4? Hold on. What's the difference between 5 plus 4 and 4 plus 5? What's the difference between the two, Morgan? Nothing. And you know that. You already know that. It's the same thing, though, as if I have 1 plus 2 plus 3 is the same thing as 2 plus 3 plus 1, right? Notice this. If I have a string of addition, meaning I've got a bunch of additions, whether it's just 2 things, 5 plus 4, or it's 1 plus 2 plus 3, or it's 10 different additions, all addition. One thing I'm allowed to do is, can you move the things around? And as long as you add it all together, can you move them around? You can move them around, right? Doesn't matter. You move it around, it's going to add up to the same thing. That's what this is showing you. That 5 plus 4 is the same thing as if you actually switch them around. And this one is the same thing as if you move the 1 from here to here. Does that make sense? You're moving stuff around. The property that this is called the commutative property. You go, oh no, how am I going to remember that? Commutative property of addition. How did you guys get to school today? You drove, right? Do you know what driving from your house to your school or driving from my house to my work is called? To commute. To commute means to move. I moved from my house to my work. You guys moved from your house to your school. To commute means to move. Do you see why it's called the commutative property of addition? Because you can move the numbers around, move them around, and it will still equal the same thing. Make sense? Make sense? It's the same thing for the commutative property of multiplication. What is 5 times 4? What is 5 times 4? 20. What is 4 times 5? Can you commute multiplications too? Right? What is 1 times 2 times 3? 6. What is 3 times 1 times 2? Just mix them around. Still 6. Agreed? You just move them around. It don't matter. This is called the commutative property of multiplication. If I have a string of multiplication, I can move them all around. It has to all be multiplication. Can't have anything else in there. And you can, and when you talk about the commutative property of addition, it can only be addition. But if you have nothing but addition, you can move the stuff around. If you have nothing but multiplication, you can move the stuff around. And you've known that. Question. You cannot do it with division. Nope. Nope. Can't do it. You're right. So, there's one last property that you have to know. And that is this. What is 4 plus 5 plus 6? 15. Do you agree that I have written the same numbers down? But in this one over here, what do we have to do first? The 5 plus 6. Do you see it? Does it change the answer? No. If you have a string of addition, it doesn't matter, even if you don't move them, it doesn't matter which ones you do first. It will still come out the same. Does that make sense? That is called the, sit up and stop tapping. It's called the associative property. Associative property of addition. Associative. It's the same exact rule for multiplication. If I have 4 times 5 times 6, what is 4 times 5 times 6? 120 is the same thing as 4 times 5 times 6. Because what's 5 times 6? 30 times 4, 120. Again, it doesn't matter which ones you do first. If it's all addition, you can do whichever ones you want to do first. If it's all multiplication, you can do whichever ones you want to do first. If it's all addition, it's called the associative property of addition. If it's multiplication, it's called the associative property of multiplication. Make sense? All I've done here is put words to rules that I think you already knew. You know what I'm saying? Okay. So, let's talk about using this here. Let's look at let's look at this. I'm gonna do one here for you. 5 times 47 times 2. In this particular assignment, I want you to use your brain. I don't want you to show your work at all. I want you to do the math in your head. Now listen. Here's the deal. If you know the rules, this is so simple. Here's the rule. First of all, how many of you want to do 5 times 47 in your head? Would that be real easy to do in your head? I'm talking about real quick. No, it takes some time. Some of you might be able to do it, but some of you would never be able to do it. It's too hard. It's too much. So what am I allowed to do? What am I allowed to do? Do you see something that I could do here that would make the numbers a lot easier to deal with? What am I allowed to do, Reed? 5 times 2. Because what is 5 times 2? 10. All of a sudden you go, oh, 10. What is 10 times anything? If you have 10 times anything, all you do is tack a 0 on the end. That's it. What's 10 times 5? 50. A 5 and a 0 you tacked on. What's 10 times 10? 100. The 10 plus the 0 that you tacked on. What's 10 times 20? Sorry, what's 10 times 12? 120. You take the 12, you just tack on the 0. So whenever you have a 10 times something, you just tack on a 0. So 5 times 2 is 10. 10 times 47. What's 10 times 47? 47. Tack on a 0. You could do it in your head. Right? You could do it in your head because you knew what rule. What rule was this? Nope. This one is the commutative because you actually moved the 2. You actually went. Look here, Sladen. You actually did this. Right? That's what you ultimately did, is you went 5 times 2 first. Then you did 47, so you moved the 2. That would be the commutative property. You moved it. Make sense? What if it was this question, though? What if it was 47 times 5 times 2? Same question. This time, what did you do first? What should you do first? The 5 and the 2. Right? Now what property was this one? Associative property. You didn't have to move anything. You just chose to do the 5 and the 2 first. Does that make sense? Okay. Question?
Did you also estimate the 47 and 50?
Not if I'm looking for the exact answer, no way. Right? If I want the exact answer, then no. And the only time you're ever going to, I always want the exact answer unless they tell you to estimate. If they tell you to estimate and you give me the right answer, guess what? You're wrong. You didn't follow directions. They'll always tell you when to estimate. Other than that, you need to give me the right answer. What about this one? What about I don't know. I mean, what I really want you to try to do with this assignment class is I really want you to try to do the work up here. If you are using the math rules, you should be able to do it up here. Okay? If you can't, fine. Whatever, get the right answer. But I'm hoping that most of you can look at this and do it in your head because you're going to use the rules that we just learned. You're tapping again, Donovan. I don't want to, that's like, 6 times now in 2 days? I need you to stop. There's no estimating on today's assignment that I can see. But what a lot of them want you to do is do mental math. Mental math. Can you do that in your head? Can you line those up in your head? I can. I can line them up in my head. I put the 4 and the 8 underneath the 3 and the 2. I just do it. And you look at it and you go, okay, 2 plus 8 is 10. That puts a 0 down there, and then the 1 gets carried. 1 plus 3 plus 4. Do you see what I'm talking about? You're attempting to do this stuff in your head. A lot of them, which ones should you do first if you're going to try and do this in your head? Yeah. I wouldn't. I would do 33 and 167. Anytime you can get a 0 down there, it makes things a lot easier. You see what I'm talking about? Anytime you can get a 0 there, it'll make things a lot easier. Put the 33 and the 167 together. What does that give you? 200. Oh, and all of a sudden, what's the answer? 224. Do you see what I'm talking about? And you didn't have to write it on paper. I really want you to try to do it in your head. If you can't, or you want to double check, whatever, you can do it on the paper too. The exercise is to do it in your head. Okay? All right, I'm going to give you your homework assignment. Today is Thursday. All right, I have